Alright, now we're going to take a look at a scene that was created in V-Ray, and we're going to kind of treat it as like a real world situation, and we're going to render out a bunch of V-Ray passes and combine those passes back together in Fusion. Um, just a little bit about this scene. It's an interior scene. There's a hole in the ceiling for skylight to come through. We have some spotlights that are kind of back in these little recesses in the wall, and the ground plane just has simple little checker pattern on it. It's not displaying properly here, but then we have teapots and Taurus knots all over the place, and they have different materials that are either only reflective, only refractive, or some of them are a little bit of both. And then other than that, it's all just basic, solid color materials. Alright, so let's see, here's the render settings. Everything is already set up for a final render here. I went ahead and set it all up beforehand. I've got the GI with the different irradiance caches saved out. Nothing special going on here. This is all default stuff. And the only thing we still need to do in this file is to save our render elements. So let's pick which ones we want to render. So come in here, hit add, and then you can see there's a huge list here of different passes that we can output from V-Ray. So let's go ahead and pick which ones we think are going to be the most useful. Go with the diffuse, global illumination, lighting. Don't need matte shadows, don't need normals or IDs. Alright, these raw passes are pretty interesting, so let's get the raw passes of reflection, refraction, lighting, global illumination. And then there's these passes. This is just a normal reflection and normal refraction pass, but then we also want these filter passes too. We don't have self-illumination. We'll get shadows and we'll get specular, and we don't need anything else for this render. So there we go. Here's our list, and the last thing we need to do is output the file. So what I'm going to do is I'm going to render to V-Ray raw image file. So I'm going to hit browse, and we'll just call this V-Ray. That's fine. You see it put this VRIMG tag on the end of this. We don't want to render to this file format. This is a file format that was created by the V-Ray guys, and it's a very cool format, but it doesn't get read in Fusion, so we can't use it. Fusion can't look at this file, so we need it to be something that Fusion can see, and Fusion can see EXRs. So we're going to change it to an EXR, and then when we render, we should get a multi-channel single EXR file. It'll be one single file that has all of these passes inside of it. So that should be very cool. Alright, I'll go ahead and I'll render this. I'll pause it and we'll take a look at it when it's finished. Alright, so here is the final render. As you can see, it looks pretty dark. The reason that it looks dark is that I rendered this scene using a linear workflow, and I'm not going to go into a bunch of details on what that is. If you do a search online for linear workflow or texture gamma or anything gamma related, it'll probably come up. It's not hard to find. So the thing you do need to know about this is that in order to view this render correctly, you need to hit this little sRGB button here. This is display colors in sRGB. If we turn that on, now it's displaying the image the way it's meant to be seen. sRGB is basically equivalent to a 2.2 gamma correction. It's not exactly, but it's pretty close. But yeah, all you need to know is that if you hit this, it'll display properly. Now, what is important to know though is that this is just showing us what the image looks like in sRGB. that is what's going to get saved out. So when we get into the comp, we'll need to make sure that we deal with this gamma change in Fusion. But that's really all there is to it. So render looks good, saved it out, so we'll jump over into Fusion and we'll start working with it. Okay, so here we are with Fusion. Let's drag and drop our loader in, and we'll drag it up here and take a look at what we got. Okay, so we have the dark version here, and it's because when it's saved out, it gets saved without the sRGB curve on it. So in order to make it display properly while we work, the easiest thing to do is to turn on the lookup table here, this LUT. So we'll turn that on, hit the little arrow, and say Edit. Now an sRGB curve is actually very similar to a 2.2 gamma. It's not exactly the same, but it's close enough to let us see what we're working with. So just toggling this on and off now will show us the final result. Okay, so with this EXR file, like I said, all of our passes are inside this one file. So in order to get at those passes, what we do is we go to the Format tab, hit this little plus sign, and now we get all of these options here with little drop-down windows. And in here you'll see all of the passes that we rendered out. And not only that, we have the red, green, and blue component of each of those. So all we need to do is set these to whatever pass we want, and then that loader will become that pass. So let's start with the diffuse. So I just change this to the R, G, and B, and that gives us our diffuse pass. So we'll just rename this diffuse. And now to create the other passes, we can just copy this, and we'll paste a couple copies around here. And we're going to work with, let's see, we want the raw lighting pass, and just the lighting pass. We also want the raw GI pass, and the GI pass. Okay, I'm gonna go ahead and set each of these up. You saw how I did that, so I'm just repeating the same process, and I'll pause it while I do that. Alright, so now those are all set. So if we take a look at them, here's the raw light, which is just the lighting information without any textures in it. And the lighting pass is the lighting with textures. The raw GI is just the GI information without textures, and GI is the GI with textures. Now basically what we do with these passes is if you take the diffuse and you multiply it by the raw light, the result of that should equal the lighting pass. And the same goes with this. Diffuse multiply by the raw GI equals the GI. So let's go ahead and try that. Connect these together, say multiply, and if we look at the result, well, okay, we have a little bit of a problem up here, but let's check these out. If we compare these two, they otherwise are the same, it looks like. Okay, so at least that's good. Let's go ahead and connect these up. We'll do the same thing, multiply, and we'll compare them. And these look like they're also pretty much identical, except for, again, that little problem we're having up here. Now, what's going on? We should probably figure this out before we go any further. Well, this is just a regular run-of-the-mill pre-multiplying problem. We have two passes that are anti-aliased, and when we merge them together, wherever they're anti-aliased against the alpha channel, some of the pixels of the background show through. So we need to fix that. So what I'm going to do is if I hold down Alt and click on the line, it adds this little elbow here. And what we'll do is we will unpre-multiply this diffuse pass. So we'll bring a channel boolean down here. We're going to divide by the alpha, and we'll set that to do nothing. Okay, so here we go. The diffuse becomes unpre-multiplied. Then we can multiply it against these passes. And actually, remember, when you're multiplying here, you have to we're drawing a blank. Oh, you're right. Make the alpha solid under the import tab. We need to do that for both of these. Make alpha solid. Alright. And it's also a good idea to just turn off the alpha in these merges. Okay, so there we go. And then these are basically just lighting passes that we can add together. So if we add those up, there we go. Alright, let's just make sure that what we have is correct now by putting some kind of color in the background. We'll just make it white. And we'll make sure that we don't really have any edge problems. So I need to swap the inputs so that that's in the background. Okay, and we get nice clean edges here. So looks like everything is all good and we can continue on. Alright, so we'll get rid of that. Now, we can move on to bringing in the reflections and working on the reflections. So let's do that. So make a couple copies here. Alright, so this one we'll call it reflection. This one will be raw reflection. And this one will be reflection filter. Alright, so I'm going to pause again for a second while I get these set up so that they're bringing in the right information. Alright, we've got those set up, so let's take a look at them. Here's the reflection pass. Here is the raw reflection. And this is the reflection filter. Now, just like the passes that we have over here, if we multiply these two together, it should give us the reflection pass. So let's go ahead and do that, and let's just see what we get. So we'll multiply these. So this should equal this, and it looks like it does. So that's good. Now, just because I know what's going to happen here, what I'm going to do is I'm going to branch this off, and we're going to start looking at the difference between these. Alright, so reflections should be added, so we want this to be additive. Now let's take a look at the entire comp here. Okay, so let's zoom in and we'll just see what we're getting. Okay, you see that? You can see it real good back here. Watch the edges. Okay, looks really nice. Little black halo around there. Okay, so we have a problem here. Now, one thing we should do is I'm going to make one more copy, and I'm going to call this the beauty pass, and I'm going to change this so that it's back to the exact output that we got out of max, so that we have something to compare to. We know what's right and what's not. Okay, so here is the beauty, and here is everything set up correctly, including the reflection pass that doesn't have all this extra stuff going on here with the filter. And if we compare those, this is still not right. We still have a problem over there. Well, maybe it's the refractions. So before we go further and try and fix this problem, let's just bring in the refractions and the specular and make sure that it's not just that we're missing those passes. So I'm going to copy this. I'm going to paste everything down here, connect it up, and now we need to change these so that this is going to become the refraction. This will be the refraction filter, and this is the raw refract. Alright, and I'm going to pause again while I set these up. Okay, so if we look at these, here is our refraction, and okay, so that torus knot back there was not refractive, so looks like we're going to have some other problem. But here's the refraction filter and the raw refraction. So in theory, we take this, multiply it by this, gives us this, and it should match the refraction pass. And we can already see, look, there's a slight difference happening here. That and that. Okay? So we haven't solved it yet. We still have a problem happening here. But let's look at all this and we'll compare it with the beauty pass. So I'm going to zoom in just so we can see some of this stuff. Alright, so here's the beauty. Here's what should have ended up being perfect but isn't. And here's even worse using the raw passes. Okay, so we still didn't get this right. Alright, so what's happening? Let's backtrack. This pass should be completely perfect, and the fact that we're already seeing a problem when we get here means that we have a problem still further up here somewhere. So let's figure out what it is that's happening back here that's giving us the problem. So let me just bring this back over where we can see it. Okay. Let's take a look. Okay, did you see that? If we look at the diffuse and watch the edge here, watch what happens to this edge once we put the raw GI on. See how it kind of bulged out a little bit? Let me go back. Okay, so that's giving us that dark edge, and really the reason it's happening is because back here on our diffuse pass, anything that was 100% reflective, or it happens with anything that was even remotely reflective, but it's really obvious with this torus knot because it was 100% reflective. So it renders it black, and the edge is anti-aliased. And if we look at the raw GI pass, it's also black and the edge is anti-aliased. So when they get multiplied together, that slight little variation in the edges here are multiplying on top of each other and kind of growing outwards. So we have pixels that are near black right here, pixels that are near black right here, and you multiply those together and they just get darker, and that makes the edge here kind of expand outwards. So we need to find a way of preventing it from doing that, because this should equal the GI pass, and as you can see it doesn't. The GI pass was all the information, or these two passes were combined and then it was anti-aliased, not that these two were anti-aliased and then combined. So we need to figure out a way to get those edges back. Now, it's kind of like when you pre-multiply an alpha, you can restore those edges. Well, that's kind of what we want to do, but we need to figure out a way to do that. And what we know is that diffuse multiplied by raw GI equals the GI pass. But what we can also do then is to say if we take the GI pass, divide it by the diffuse, that should equal the raw GI pass. So let's try that, because we know that everything is correct here, so maybe if we plug that into the equation, we'll get something that we can work with. So I'm going to pull this over here, and let's grab a channel boolean. We'll connect these guys up, and we'll switch this over to divide, and let's just set it to do nothing. Alright, cool, check it out. We got the raw GI pass, but we restored those pixels on the edges. That anti-aliasing is kind of removed now. So here it is with the anti-aliasing, here it is with those pixels restored when we divide these two to create this pass. So now what we should be able to do is, now that we have this separated, we should be able to just put it back together again. So if we take these, set it to multiply, we're really just, we should be going right back to what we had. Okay, so this should equal this, and it does. So now if we wanted to, we could have adjustments made here and still be able to put everything back together properly without getting those dark edges. So this could then be connected up in here, and we could do the same thing with our lighting passes. So let's do that. Connect these two together, set it to divide and do nothing. And yep, you can see it's the same exact thing, only it's fixed our edges around these objects. It also kind of fixed it back here too. Oops. So you can see here and here, there's still just very slight change back there, but the biggest noticeable one is right in here. Alright, so we can do the same thing with this. We're going to multiply these back together. Alright, and now this and this should be identical, and since we have them separated, we could make adjustments there. So now we can connect these up, and we are no longer using these raw passes at all. We've created our own by dividing, and now if everything gets put back together, hopefully we won't have a problem. So let's take a look at the final end result. So here is this kind of top row where we're using the reflection and refraction just straight as they were, and the beauty, and take a look at that. Now, aside from the specular, which we haven't added yet, those are exactly correct. Alright, now let's actually go up here and just make sure that we are okay. We need to fix the pre-multiply problem that we have up there. So I'm going to slide this stuff down, and let's bring in a matte control right here. Turn on post multiply, and now do they match? Yes, they do. Okay, so now at least our top row is set up right. And let's, before we go any further, let's just bring in that specular pass. So we'll set this to specular. Okay, and that should be added. Alright, now let's just make sure. Here's the beauty. Here's the end result of our crazy flow here, and they are identical. Okay, so then what we need to do is figure out how to make this stuff down here work. You can see the way it is right now is not matching. And it's really just the same problem that we had back here, and we can fix it the same way. Instead of using a raw pass, let's make our own raw pass. So I'm going to copy these and just bring them down here. And we're not going to use raw passes anymore, so let's get rid of those. We're going to make our own, and to do that, it's just like before. We're going to connect these up. We're going to divide and do nothing. Okay, so if we look at the result of that, okay, we've gotten the edges fixed. There's no anti-aliasing. Just like when we do the undivide or the unpre-multiply, we get the white background, but it won't matter. So we have the reflection filter divided. Now when we put them back together by multiplying them, it should equal exactly this raw reflection now. I'm sorry. This should equal this, and they do. Reflection, everything separated and then put back together, same thing. Alright, so that's working. We need to do the same thing over here. Okay, when we divide this, okay, our edges are restored. Again, we're on white, but it otherwise is the exact same thing as the raw pass. And then we multiply them back together, and they should be identical, and they are. So finally, the last thing we should hopefully need to do here is to put our specular on and take a look at the final result. Alright, compare it with the beauty. Looks identical. Let's just zoom in real close, make sure. That pass, this one, they're all the same. And let's just check up here. Okay, we're not done. Part of the problem was that we have this white background, and when we multiply it together, it's using the alpha channel. So let's get rid of the alpha channel, and we're probably going to need to make these guys solid. There, that one goes. Now do we have the same problem here? So make alpha solid, and we don't want to use the alpha. Now everything should match, and it does. Alright, so there we have successfully put all of this stuff back together again, a couple of different ways, but we've done it without using any of the raw passes, at least not directly. We're creating our own, and that's the, I guess that's the trick or the secret to using raw passes at all. The way they come out of the renderer won't directly work. The math is correct, but the anti-aliasing is what will get you. If you don't use those passes and create your own, then you can split everything up using raw information and put everything back together again exactly the way it should be. Now, one last thing I just want to show before we get out of this file is, while we were working, you see all this ugly banding and weirdness that's happening there. That is because of this LUT that we're using, the 2.2 gamma, and it's just, you know, it's just a little display error that's happening because of that. But really what we want to do is apply an sRGB curve and not a 2.2 gamma because they are slightly different. So just to show you, I'm going to change the gamut here and select sRGB, and now that problem is gone. So basically, whoops, let me connect these up. If we look at this and compare it to this, problem's gone. Okay, so there we go. Everything taken apart and put back together again. So just to recap, the reason we had to split all this stuff out the way we did by dividing instead of using the raw passes is because of the anti-aliasing. If you rendered your image without any anti-aliasing, then you could combine everything just the simple, easy way, without dividing, without anything, just multiply them together the way it says it should work, and it will work. And really it's just that anti-aliasing that'll get you. So think about it this way: in V-Ray, when you render the scene, basically all of the math is performed, all of the multiplying, all of these different things are done, and then the image gets anti-aliased. But what we were trying to do was have a bunch of anti-aliased images and then do the math, and it just doesn't really work quite right that way. So it's the anti-aliasing, and you can get around it.